see, before we go to the written part of the solution here, of the fourth graph, I would actually suggest that we spend some time to just clarify the concept of whether the graph, the second graph that's given to us, which means the velocity displacement curve, could it be practically possible in a vertical projectile? Something that we've been, you know, bugged about right the moment we see about we see the question, right? So I just want to make sure that we don't have that confusion anymore. So let's spend some time to understand that part here. Okay. So imagine a setup wherein an ball from the ground is projected upwards, which means it's in a vertical straight line, a vertical projectile, and it is launched from with a velocity of u is equal to 30 meter per second upwards. And we know that acceleration due to gravity will be acting downwards with 10 meter per second square. And of course, the sign of g will depend on the chosen direction. Now, we have not yet discussed motion under gravity. Yes, I do understand that. I'm realizing the impact as well. Now, I would suggest that let's not dive much into the sign convention here. So I'll keep it, at the surface level. But then what's important is to understand the overall nature of the graph here. That's very important. In fact, it's crucial. Okay. So the assumptions, the one I was talking about, the sign convention actually. Upward direction is taken as positive. Okay, that makes sense. Upward is positive. And the ground is taken here as the reference origin. And displacement is measured from this point. It is measured from the ground to all the points above it. And of course, positive is upward is positive and negative is downward. So anything which is acting upward will be considered as positive. Anything that is acting downwards will be considered as negative. Now, the practical physics that happens here is the object is moving upwards, right? And we know that gravity will be acting downwards always. Gravity is acting downwards. Now, velocity is acting upwards because it is being projected upwards like this. But then it's slowing down. What does that mean? It means as the object is going up, the velocity vector will get smaller and smaller and smaller, which means the magnitude of the vector will become smaller, but it will keep following the same direction. It will keep moving upwards. Okay. Now coming into the calculations, which makes use of equations of motion. Initial velocity is 30 meter per second. Final velocity is 0. If we use v square is equal to u square plus 2as, what we get is s is equal to 45 meter, which means the maximum height attained by this vertical projectile is 45 meter. To be more precise, we'll add a positive symbol. Why? Exactly, because going up is positive, coming down is negative as per the reference, chosen reference. So yes, the maximum height is 45 meter. What about velocity at any time? It is given by the equation v is equal to u plus at, right? It is given by the equation v is equal to u plus at, which is u plus what is a? Acceleration due to gravity is acting downwards. Therefore, it is taken as minus g times t, which gives us u minus gt. Okay. Likewise, minus half gt square and not plus gt square. Okay. I hope that makes sense. Please pause the solution here. Write it down one more time with me. Think of it. Question yourself, and ask a question to yourself if that makes sense, right? The direction of the convention, the sign convention used for any physical quantity going upwards as positive and coming downwards as negative. Now, don't worry if you find it still confusing. We got plenty of problems that we'll discuss in the solution of it by using sign conventions. Okay. Now, this equation v is equal to u minus dt and v is equal to ut minus dt square is actually a function of t, which means if you input time, then it will give you the output, the corresponding output at that specific instant of time for both velocity and for displacement. Okay. Now, motion here is continuous, which means we can have infinite instants, but then it's not practical to list all those infinite instants. So we sample the motion, which means we take dt is equal to a small time gap between two observations and t is equal to 0, 1, 2 seconds, and then apply dt there and calculate values at each instant. Now, you might be wondering what exactly is happening here. What exactly am I trying to take you through? See, we have the second option given in the question here as a velocity displacement graph, which is which is given as a circle. So we are plotting the same. We are plotting the same graph, which is velocity displacement graph for a vertical projectile, and then we are trying to check if that will result in a circular graph or not. Okay. Now let's calculate the values at each instant. What do I mean? So say the input is at time t is equal to 0. What is v of 0? It is u minus gt. T is 0. So 20 minus 0, it was 20 meter per second. Right? And then, oh, excuse me. When we have t is equal to 0, the corresponding displacement is y of 0, which is half ut minus half gt square. T is 0, gt square, t is 0. So displacement is 0 meter. Likewise, at t is equal to 1, we got 10 meter per second and 15 meter. At t is equal to 2, we have 0 meter per second and the corresponding 20 meter. Okay, so on and so forth. So what we will do is we will plot the values like this for dt, which means dt is equal to 0.20 seconds. We pause the motion every 0.20 seconds. So we take a snapshot at each pause, which means at every 0.20 seconds, we will find out the corresponding velocity and the position, distance, displacement of the object throughout this vertical projectile. How? First, we will start at t is equal to 0, which exactly is the launch moment. And then t is equal to 0 will be increased by t is equal to 0.20, 0.40, 0.60, and adding 0.80, 1, 1.2, 1.4, etc. And at each time, we'll substitute the value of t into vt to get velocity, to yt to get displacement as well. Okay. Now, once we have this, we will write this in the form of a table and evaluate. I mean, we'll write dt is equal to 0.2, put inside a table, put in a row, and then we'll keep on evaluating this till the complete motion of the vertical projectile happens. And then we will tabulate the whole values. And then using y-axis, x-axis in these values, we will try to understand multiple graphs. Okay. So say, for example, this is what we have. Time dt 0.20, 0.40, 0.60. The time interval between these instances is 0.20, which is dt. The corresponding displacement y in meter, the corresponding velocity For example, at the launch instant, displacement is zero because the object is still on the ground and the launch velocity is 30 meter per second from the ground. Whereas when it is at the top, at time t is equal to 3 seconds, at the top, the velocity is equal to zero. Why? Because the object is momentarily at rest and the corresponding displacement is 45 meters. Okay. Similarly, we have the same for downward motion as well. Now, if we plot the velocity time out of this, if we select the velocity time data from the table we just got now, if we plot only time and velocity, right? And if we note the 2 points, which is velocity 30 and velocity 0, and if we plot it on the graph, what we get is the velocity is 30 at time t is equal to 0, and at time t is equal to 3 seconds, the velocity is 0, giving us a straight line for the upward motion. What will be it for the downward motion? We have the table, time, corresponding velocity. And for the downward motion, we get another straight line, this time going to negative velocities. And if you compare, if you draw these two graphs in one, velocities varies from 30 to minus 30. Time t is equal to 0, 30, t is equal to 6 seconds, it is minus 30, and at t is equal to 3 seconds, it is 0. Now, how do we interpret this one? So this much region is time of ascent, and later what we see is time of descent. And at this point, the ball is at the maximum height, which is why velocity is equal to 0. Why is velocity 0 here? Because the y-axis, because the graph, it crosses the x-axis, which means the y coordinate is 0. What is the y coordinate? Velocity, and therefore velocity is equal to 0 here. Okay. So these are very subtle concepts, but the kind of impact they make in your problem solving attitude is different. Because as we go on to the next set of questions, there are multiple questions that are based on graphs, and then maybe a different set of questions which are oh, okay, maybe let me just pause that explanation here. Let's focus on only the graph that's given here. Now, distance versus, okay, I think I should continue that. What I was trying to say is there are many questions that are based on graph. It actually means that the questions coming up for JEE Mains, they're not just asking you if you can solve it numerically using equations. Rather, the question is trying to evaluate if you can understand the physics behind it. Because if you understand the physics behind it, you should be able to explain the mathematical part and the analytical part as well, which is where graphs comes into picture. Okay. So that's why you see in the recent past, there are many questions that's coming out of graphs. And once there is a question, an option in the graph, I mean, when there's a graph and there are four options, of course, there's maybe one is correct, or maybe more than one is correct. But then why is the graph which is incorrect? So we need to understand the concept behind it, because that might be a potential question coming up for the next year. Or maybe that may have a concept that will help you to understand the later concepts, maybe in the same chapter or in the other chapters as well. Okay, so that's the reason why I'm taking you through this depth of this explanation. Now coming to distance versus displacement in vertical projectile motion. What is displacement? We know that displacement tells us where the particle is relative to the origin, the position. It has direction and sign. It can increase, decrease, or become zero. Correspondingly, for distance, it is the total path length traveled. It has no direction. It is always positive. It never decreases with time. Okay. If we calculate the displacement for the upward motion, which is from 0 to 3 seconds, the position of the object is such that it moves away from the origin. So, yes, y will increase from 0 meter to 45 meter. This comes from the table. And this increase in y means the particle is getting farther from the ground, which means as the value of displacement is increasing from 0 to plus 45 meter, this plus means that the particle is getting farther from the ground. Okay. Okay, wait. Let me just ask you another question here. What would this mean if it is negative 45 meter? That is near to the ground? Or is it something else? Put for thought. Now, for the downward motion from 3 to 6 seconds, something which is very important, I want all of you guys to make sure that you clarify this concept here. Okay. At the highest point, when time t is equal to 3 seconds, y is equal to plus 45 meter, which means the ball has traveled a vertical displacement of 45 meter from the ground. Okay. After this, the ball has started the descent. So the ball was here. It traveled 45 meter. It reaches up here. And then the direction of velocity changes. It was going up like this. Now it's coming down, right? And then it will trace all its path back to the ground. Now let's see what happens during this travel when it's coming down. Now as the ball comes down, it is getting closer to the ground, which means the origin, the reference. Therefore, its displacement from the ground reduces. I didn't say the displacement becomes negative. I said that the displacement becomes smaller in values. It is reducing. Therefore, when the object is coming down, y will decrease from what? From 45 plus 45, not to minus 40, rather to plus 40, plus 30, and eventually to 0. Therefore, the answer to the previous question. So, yes, displacement decreases from 45 meter to 0 meter. It does not become negative. Why? Because the particle never goes below the origin. Displacement is negative only if the particle is below the origin. And what is the origin here? The ground. So displacement is negative only if the particle goes below the ground, if that makes sense. Okay. Right. Now, to calculate the actual values of displacement, we use the equations S is equal to ut minus half gt square, u is 30, and we know the function, this is a function of time. And if we substitute the values of t for the dt intervals that we are choosing for the same calculation, t is equal to 0.0, 0.20, which means dt is 0.20, and calculate the corresponding velocity of displacement. And if we plot the graph, what we get is an curved graph starting from 0. So this actually represents graph for ascent, right? And what is this? This here is the maximum height, the h max. Okay. And of course, you know that this is equal to u square by u square by 2g. What is u? It is 30. So this is 30 times 30 divided by 2 into g is 2 into 10. 10 by 10, 30 times 3 is 90. 90 by 2 is 45. Again, you get 45 as the maximum height. So h max here is equal to 45, right? So yes, this was the kind of assessment that I was trying to tell you, that the analytical part of, or rather analysis of graph, that's really important when it comes to JEE means, for that matter, the process of learning physics in itself. To understand the physical meaning of graph, to understand to interpret the physical aspects of the two-dimensional graph that's given to us, or maybe to make sense of what's happening in real and explaining it by looking at the graph, like we did. Okay. Now, if we plot the displacement time for the downward motion, we get a graph which explains the process of descent. So the ball was here, it was launched up here, it reaches 45-meter, and now the same ball, it retraces its path and it's come down to its original position, right? So the descent. And what happens in the descent? From the height of 45-meter, it travels back to zero in 6 seconds, which means it comes back to the ground. So if you consider the complete motion, what you see is a parabolic curve here, starting from zero, reaching to a height of 45-meter, and then coming back to the ground at time t is equal to 6 seconds. Okay. Now, what will be the case for distance for the same calculation? The setup is same, which means it's a one-dimensional motion, it's a vertical motion, it's a vertical projectile motion. It is launched at 30 meter per second. Acceleration is still acting downwards. The ground is origin, it is thrown upwards. All those calculations remains the same. What varies then? Time of flight is 6. Maximum height attained is 45 meter. The corresponding time is t is equal to 3. Does this affect the calculation of distance by any chance? Now, very important. Please make note of this. The path length is equal to the vertical rise for the upward motion. So during the upward motion, distance traveled is actually equal to the displacement itself, which means if at t is equal to 0, the distance is 0, the displacement will also be equal to 0. If t is equal to 3 seconds, displacement is 45 meter, distance is also going to be equal to 45 meter. So the distance time relationship during upward motion basically is the same as that of velocity, of displacement, my bad. Which means as displacement goes up from 0 to 45, distance increases from 0 to 45 as well. It exactly same numerical values as for y of t, which is displacement. Now, what happens to the calculation of distance in downward motion? Now the particle has started to move downwards. This is where the difference appears. What's happening physically? Particle is still moving. It's started from the origin, it goes to the maximum height, it comes back. It is still covering the path, right? So the distance must increase, unlike displacement, which was now reducing. Okay. What's happening to displacement now? Displacement is decreasing because the particle is returning towards the origin, but distance is increasing because the path length overall is increasing. Which means at t is equal to 3 seconds, distance already traveled is 45 meter. After that, every bit of downward motion adds more distance, whereas reduces displacement. Okay. So distance at time t is 45 meter plus distance fallen after 3 seconds. And what is distance fallen after every 3 seconds? We'll come to that. So important contrast to note here that at the same time t is equal to 4 seconds, displacement from the equation is plus 40 meter. My bad, it's not 40. You should prefer write it as plus 40 meter. And if we interpret it, it means that particle is 40 meter above the ground or it has fallen 5 meter from the top. If we draw it like this is the maximum height here, which is 45 meter. This happens at t is equal to 3 seconds. At t is equal to 4 seconds, the object is here, say, which is at 40 meter. Or in other words, we can say it is 5 meters from the top. Yes, I'm thinking exactly what you're thinking right now, that I should have include the diagram as well for better clarity. My bad. Maybe for the next solution. Okay, now another question that would come to your mind now is why is there no single distance equation like we have for displacement, which is y of t is equal to 30t minus 5t squared? It gives the displacement, not the distance. Because distance depends on how much path is covered and not on the position relative to origin. Which means we cannot have a simple direct equation of motion applied for distance. I didn't say there cannot be an equation for distance. I'm saying that there is the equations of motion cannot be directly used to calculate distance. So distance must be found by adding the path lengths or the magnitude. Okay, let me just take you through what this is. So displacement answers to make a comparison here. Where am I relative to where I started? Whereas distance answers how much have I moved in total. For the upward motion, which is from time t is equal to 0 to time t is equal to 3 seconds, distance is equal to displacement. But what happens after that? For the downward motion from 3 is equal to t is equal to 3 seconds to 6 seconds, distance increases with 45 meter plus 45 minus yt, which gives us the equation as 90 minus y of t. Okay? Now, this is the distance time graph for the upward motion, the values and the graph. What do you think will be the case for distance time graph for the downward motion? Will it come down? Exactly, it shouldn't be coming down, as in the case of displacement time graph, where the graph exactly was symmetric. And in this case, it wouldn't be. Why? Because distance is increasing and therefore it will rise further. So if you plot the complete motion for distance versus my bad, please make a note of this here. The title for this axis would be distance and time, and you see it's increasing from 0 to 90. Okay. And finally, we come to the option that we have in the question, right? Which is the velocity displacement. Now let's see what's the velocity displacement for the upward motion, which means at a given height, what is the velocity of the object? Now, by sign convention that we have chosen so far, we know that during the upward motion, velocity is positive. Yes. Velocity continuously decreases. Yes. For each displacement, which is continuously increasing till t is equal to 3 seconds, there is only one velocity. Okay. And what is the equation that connects v and y? It is v square is equal to u square plus 2as, and you substitute this and you get v square is equal to 900 minus 2y, which means if you take the root of this, v is equal to root of 900 minus 2y should give you two values, plus 900 minus 2y and minus 900 minus 900 minus 2, 20y. Now we are considering here only the plus part because the motion is right now going towards the upward direction, which means velocity is taken as positive. Okay. So this is the table and graph for velocity displacement for vertical projectile. 30 meters, it reduces and it reaches zero when the height is 45 meter. Okay. Height to displacement. For the downward motion, velocity versus displacement will give you another curved one starting from, now see the way to read the graph, starting from 45 meters and then ending at t is a height is equal to 0 meter at velocity minus 30. Okay. And if we compare these two together, what we have is the object was projected up with a velocity of 30 meter per second. And when it reaches down, it approaches the ground with a velocity of minus 30 meter per second. And again, you have a parabolic curve here. Okay. Right. Now, the question, the actual question, which is, can this velocity displacement graph ever be a perfect circle for a vertical projectile? Not possible in physical space for vertical projectile motion. Why? Because for a vertical projectile motion, the displacement relationship is v square is equal to u square minus 2as. And if you plot v square y, this is not the equation of a circle, right? Why? Because velocity is squared, displacement is not squared. Coefficients, my bad. Coefficients are not equal. So the shape you get is a curved loop, but is not a circular one. Okay. Now for vertical projectile motion, the graph that we have plotted so far, it already has half of the circle, or maybe uh, close to an ellipse. Why can't we assume that the other half as well is a circle? The graph already contains all the physically allowed states of motion. Considering the other half would actually mean that we are trying to plot states that never occur physically for a vertically, for a vertical projectile under gravity, which means we have this graph so far like this. And then if we assume that if this much is correct, because at one displacement there are two corresponding velocities, one which is plus v and minus v, it should also be true for the rest half of the circle. But then for a vertical projectile, under gravity, such states practically, physically doesn't exist, which means a closed curve in phase space clearly implies that the system repeats itself in a loop, right? Which never happens in a vertical projectile. So a vertical projectile never repeats the state. So its Vy curve cannot be closed. Hope that makes sense. Yes, see, after writing down all this, I do understand that you spent close to 2 hours for one question, which actually means um 2 hours, 120 minutes, 4 options, 30 minutes. So that's close to 30 minutes for every option. Even if you watch it in 2x, it will be close to 1 hour you watching this complete solution for one question. Now, again, see the whole purpose of doing this practice of previous year questions is to make sure that you are prepared well for the next 2026 paper, right? And as we go to the next question, the next immediate question, which is based on a circular track, the calculation of velocity, I'll tell you why practicing PYQs is important. Okay, so you might be frustrated with this, with a significant amount of time that I've drained, and of course the emotional and the mental drain, you know, bombarding you with lots of concepts, trying to connect with chapters that you haven't learned, motion in a plane, motion under gravity, oscillations. So, I've been taking to all of this in just one simple question, and you've just started the course. I do understand that's overwhelming, but trust me, appreciate the process, enjoy the process. By the time you finish this course, I can guarantee you, you will feel. I can't just tell you how many times confident you are now, but I assure you that you'll feel way, way more confident than you are right now. Okay, confident not just for the upcoming JE mains, confident for physics in general, confident for your reasoning process. Okay, 5 more minutes, and you'll understand why is every question, every PYQ significant. Just 5 more minutes. Okay.